My name is Varun, and today I'll be taking you through my assignment for augmented reality. In this assignment, we needed to implement stereotypic rendering, or rendering by two cameras and then combining them into one, just to give the illusion of 3D or depth without actual 3D. So we use the typical red and cyan channels for this thing, and we have the classes. The left eye is the red pass and the right eye is the cyan pass. I'll just go over the code a bit. In the main render pass, we're checking whether we have to get the anaglyph or not, whether it is calculating the anaglyph or not. If it is calculating the anaglyph, then we are further checking whether it's a Toed-In method or whether it's asymmetric Frustum rendering. So both of these functions have been written in the camera class. So we are getting the eye offset. If it's the left eye, it will go till -1. If it's not, it will go for +1. So then we're just calculating some formulas. We're calculating the view matrix essentially for the camera, since we modify the view matrix for Toed-In rendering. This does present some artifacts like stretching and fisheye kind of effects, which we will be looking at. For asymmetric rendering, again we have a function in the camera class where we are calculating the projection matrix. So instead of the view matrix, we are calculating the projection matrix, and we are just passing them into the uniforms accordingly. We have the projection matrix, the view matrix, and then we are passing the shader through which we are rendering the thing. Then we're just rendering our scene once, and then we're doing the same for the right eye. And yes, we are disabling all the colors except for the red one, and we are disabling all the colors except for the cyan, green and blue, that is cyan. We're clearing the depth buffer, and then we are going to do the exact same process and render the scene again, and there we are enabling true colors towards the end. So that's the whole pass. This is a 2-pass rendering method in which we are performing it for the left eye once and then for the right eye. So yeah, we'll move on to the application. So there's the application. This is just the basic scene, and in the camera tab in the GUI, you can enable anaglyph, then you can choose Toed-In, or you can choose an asymmetric Frustum. So as you might be able to see that we are able to indeed see. Okay, I'll just put this towards a bit of some other color, just so it's a bit more visible. Yeah, so now you can see that we have a left offset and we have a right offset. This has been done with the help of interocular distance or IOD, or the eye distance. So you can change it or reduce it. It can even flip the thing. So the usual interocular distance for the average human eye is 65 millimeters, so 0.665 represents that. The convergence distance is nothing but the point where the two things will converge. So distance between the camera and the screens. So we'll just keep this on 2. That's a default or the basic value usually. So if you view this scene with your 3D glasses, you might get the illusion of depth. So right now we don't have any shadows, so we'll just do this. And now if you see this scene, right now it's working in asymmetric Frustum. So you can also cycle through the modes using M. So this is the normal mode, this will be the Toed-In mode, and this will be the asymmetric Frustum. So you can just press M on the keyboard. So switching to Toed-In, you can see that we have some issues, that if you go too close to the object, we are getting some clipping and we are getting some distortion in the object. Switching to the asymmetric Frustum, we can see that this problem has been solved due to the methodology that it follows. So yeah, I'm going to disable these objects and make a new object. So this is a procedurally generated city that we made in a previous assignment, and this has various materials on it. This has specular maps as well as, so this has specular maps and this is normal maps. So I'll just modify the lighting a bit. So we even have a skybox if you want. I find this one good. can disable the skybox, but it will still count for the lighting. And I can update the PCG using this menu. Okay, so now if we look at the thing using a white background, and I'll just go and enable the anagraph rendering for Toed-In method. Now you can see that we have a big offset of left, of right towards the left and to the right for each object, and this will give you the illusion of depth. Right, I'll change the FOV. We can change each parameter for the camera itself. So the field of view, I'll change it to 90 since that's the generic human FOV. So I'm assuming that this would be looking a lot better than before. Yeah, so like you can see that on the left we have the offsets for the red channel, and on the right we have the offsets for the cyan channels. Then we can change the near clipping or the far clipping. So if we change the far clipping and reduce it to something like 10, so you can see that it's clipping out the things for us. We can change it on the fly. So let's keep it on 100. And the near clipping, again, near clipping is nothing, just the distance at which the clipping of objects start once the camera is close enough. So as you can see that if I increase the distance, more of the object will be clipped as I go near it. I'll just keep it on 0.01. Yeah, so these are the basic features, and I have a rotate feature for the camera. So if you want to view the city from a certain angle, I would suggest that you can just use this feature. 25.25. So now it will rotate around your current view, and you can just keep on viewing the city. If you look through your glasses, this should give you a depth of 3D. So if I go closer to this building, it should appear to be zooming in. It should appear to be coming out of the screen. And one great way that I found out to know whether it's 3D or not is just sticking out your finger towards your screen, and at least me, I get the feeling of touching the object without actually touching my screen, which does prove the fact that it is just faking 3D, or it's giving the sense of depth to us. So again, we have M for normal, M for Toed-In method, this one for Frustum viewing method. So yeah, also one more feature that I have is flipping the channel. So suppose that your red channels are on the right, you want to flip them, so you can just flip them for the Toed-In method, or you can just flip them for the Frustum method, so in case you need that on the fly. So yeah, this was my assignment, and thank you very much for watching. It was a very good assignment in which I learned a lot about 3D and virtual reality in general. Yeah, thank you very much for watching. See you next time.